Today's lesson preview is going to be over writing, graphing, and solving inequalities with an emphasis on multiplication and division. For our first two examples, we are going to write an inequality to match the graph. Our first graph, we notice that our line is going to the left of -2. So that means all of our solutions, or our x, is going to be less than -2. Now, since it's an open circle, that means that all of my possible solutions have to be less than -2. They're not going to be equal to -2. So I'm not going to draw that line underneath my less than sign. I can also turn this around and say that -2 is greater than x. And we can even check to see if we're correct. So I could choose -3. So -2 is greater than -3. I can choose -4. -2 is greater than -4. All right, so next we have our graph, and it shows that our line is going to the right of 10. So I know that x is greater than 10, but we notice that our circle is filled in at 10, so it could also be equal to 10. And then I can write that the other way. 10 is less than or equal to x. And think about it, all of our possible solutions are greater, so the alligator mouth needs to be open to the x. It's open to the x here, and it's open to the x here. For our next two examples, we're going to write and graph the inequality statement. So first we have a group must have more than 10 people to receive the group rate. So a group must have more than 10 people to receive the group rate. So we're going to give x as the group, okay? And that group needs more than 10 people, so we know they need to have greater than 10 people in order to receive the group rate. We can't say equal to because 10 is not more than 10, so it has to just be greater than 10. We could turn this around and also say 10 is less than x. So I'm going to number my number line 10, 11, 12, 13, 9, 8, 7. So we're going to open our circle on 10 because it's not going to be equal to 10. It's only going to be more than 10. All right, so now we have a minimum order of $25 is required for free delivery. Okay, so a minimum order of $25 in order to get free delivery. Okay, so my order is my variable, and it needs to be a minimum of 25. So the smallest it can be is 25. So that means I need to spend $25 or greater. So the amount of my order needs to be greater than or equal to 25. I could also turn that around and say 25 is less than or equal to x, the amount that I need to spend for my order. All right, so now we're going to go ahead and graph this. So 25, 26, 27, 28, 24, 23, 22. All right, so this is going to be a closed circle because I could actually spend $25 and get the free shipping, or I could spend more. So I'm going to draw an arrow to the right because 26, 27, 28, and so on is going to be more. For the next two examples, we're given an inequality, and we are going to solve and then graph and also list 3 possible solutions. So I have 6 times x is less than or equal to 77. Okay, so I'm going to draw my balance, and I want to isolate the variable, And right now it's multiplication, so I am going to do the inverse operation, which is to divide. So 7 divided by 7 and 77 divided by 7. Well, 7 divided by 7 is 1, so I have 1x is less than or equal to 77 divided by 7, which is 11. So I'm going to go ahead and graph that. 11, 12, 13, 14, 10, 9, 8. All right, so I'm going to close my circle on 11 because it could be equal to 11. Now I'm going to read this again. X is less than or equal to 11. And if you notice, the alligator mouth is open to 11, so 11 is greater, meaning all of my possible solutions need to be smaller. So I'm going to go to the left. So this could be 9, 10, and it also could be 11 because it could be equal to 11. All right, so we're going to do the same thing. We are going to solve our inequality. So I'm going to draw my balance. I want to isolate the variable, and I notice that I have division. So I'm going to use the inverse operation, which would be multiplication. So times 6 times 6. So that will cancel out, leaving me x alone, which should be greater than 54 times 6. So we're going to go ahead and do that off to the side. 54 times 6. So 6 times 4 is 24. 6 times 5 is 30, plus 2 is 32. So we get 324. So x is greater than 324. All right, so let's go ahead and put these on our number line. 324, 325, 326, 327. Sorry, my handwriting's kind of bad right now. And 323, 322, 321. All right, so we are going to have an open circle on 324 because it's not going to be equal to 324. My solution is only going to be greater than. And if you notice, my x is being eaten by the alligator, meaning it's a larger number. So all of my solutions should be larger. So I'm going to write possible solutions could be 325, 330, and 500. All of those are greater than 324. For our last two examples, we are going to have a word problem, and we need to write the inequality, then solve it, and lastly graph it. So Keith is saving money for a drone. He will work the next 8 weeks and earn at least $40 per week. What is the total amount he will save? Since we don't know the total amount that he's going to save, that is going to be our variable. I'm going to use the variable t for total. Okay, so I know that he's working a total of 8 weeks, and he'll end up earning 40 each of those weeks, at least. So what I'm going to do is I'm going to take my total and I'm going to divide it by 8. And when I do that, it needs to be at least 40. So it could be equal to 40, but it could also be greater, because the least it can be is 40. So it needs to be 40 or more. Okay, so we're going to go ahead and solve this. It's very similar to when we solved equations, but this time we're using an inequality. So t, the variable, needs to be isolated. I notice this is division, so the inverse operation is going to be multiplication. So I'm going to do times 8 on both sides. So t is greater than or equal to 8 times 0 is 0, and 8 times 4 is 32, so 320. All right, so we have 320, 321, 322, 323, 319, 318, 317. All right, so this is going to be a closed dot on 320 because it could equal 320 or it could be greater. All right, so next we have the school PTA would like to raise a minimum of $3,000 in the cookie dough fundraiser. If each container costs $15, so each container, how many does the school need to sell? Okay, so X is going to be how many they need to sell. So if I know that each one is 15, I could multiply X by 15, and when I do that, so let me write that, 15 times X, that needs to be a minimum of $3,000. Okay, so let's think minimum. So the very smallest it can be is 3,000. So it could be equal to 3,000, but it also could be greater than. So 15 times X needs to be greater than or equal to 3,000. So we're going to solve it, isolating the variable using inverse operations. So since I'm multiplying, the inverse is division. So X is alone. 3,000 divided by 15. So we're going to do 3,000 divided by 15. 15 does not go into 3, but it goes into 30 twice. And when we do that, we get 30, subtracting at 0. And then we can go ahead and just add 2 zeros at the end. So our answer is going to be X is greater than or equal to 200. So let's go ahead and graph this. So 200, 201, 202, 203, 199, 198, 197. So this is going to be a closed circle on 200 because it could equal 200, but my solution could also be greater than.